All right. It's recording. Yes, great. All right. Well, welcome. Week 5. All right. So, what do you guys think of the PA so far? The programming assignments. Is there any problems? Any difficulty? What I'm sensing off of Piazza that there's a little bit of confusion with the factories. So I'll go through that a little more in detail. But just in general, what I want to do is kind of get through a little more material today because we go off on some of these design discussions and then we kind of leave some material on the table. So let's push forward a little bit faster. And then we also, I'm able to stay here tonight for another 2 hours. So I can stay here till 11 o'clock for more office hours. And then a few students wanted that extra coding session that I did last week. And I was just curious if that was helpful. Okay, nobody was on, I guess. All right.
Yeah, I wasn't on that.
Yeah, it's just we have in this class right now, there's very different in experience. There's programmers who have programmed a lot, and we have some programmers who are a little bit new to it. And so what I want to do is try to help the students who are like struggling a little bit and maybe just need to see more demos of the stuff. So I do some live coding sessions to kind of help them out. And so those coding sessions I record and also post up on D2L, so you can see those as well. All right, let's talk about factory. All right, so the factory. So what I did here is I made simplified patterns, and so to kind of more illustrate the UML to code relationship. And so let's talk about the factory because that was in the homework. All right, so the factory is basically the concept of the factory is it's a class that's going to allow you to construct or create objects for you on your behalf. And so here's the UML diagram. All right, so so here I just did one with phones, right? So we have iPhone, Pixel, Samsung's, OnePlus, and the factory is going to basically create, so it's going to spawn and create the phone on your behalf. So the calling code is actually quite simple. You create a factory, and then at that point here, you can just sit there and say call create and pass it parameters. And these parameters can be one-to-one. It could be a few parameters that expands into many parameters. You can hard set stuff in the factory. There's a lot of different ways to kind of go about it. So the idea is that when you're inside a factory, the factory will kind of expand. So we have the client, and the client's going to communicate to the factory. And the factory, it doesn't really matter. You have, you can make an abstract factory and then, specialize it. So if you have a whole, you want all your factories to kind of conform to a certain style, you can do it that way. But basically, this thing's going to create it. And this method is going to basically spawn, and it's going to create, your objects. And so in this case here, it's phone. So I have, all phones have certain properties in common. So, and it has an abstract function, call, an abstract function, text, abstract function, email. And, and these are the different factory, different phones. So iPhone, Pixel, OnePlus, Samsung. And what you do is you pass in parameters here, and then basically it's going to return the phone back to the client. Now, the first question is when I first kind of got into factory pattern or factory method, which is, well, why don't we just call the methods directly? Why don't we just call the actual constructors directly? And this is, if you're doing one or two things, that actually makes a lot of sense. But if you're going to sit there and build and have you want to basically abstract the construction phase from and kind of encapsulate it here by just request from the client. So the client can sit there and request, I want a iPhone, I want a Pixel phone, and then can pass in parameters. I want it with this much memory or color or whatever. The factory then will create the object on your behalf and then return the phone back to you. And this is a really interesting approach where when you have to create many things, different things encapsulated, and you can basically put a lot of logic and functionality here in the factory. So let's look at the factory for a second. So here's let's go with here a simple 1+, right? 1+, and I just stubbed out the methods here to kind of show that they're working. Here the kind of parameters here, I just did color and the amount of memory, how many gigabytes of memory. And so to construct a 1+, it's just color and memory. Pretty straightforward. We just pass this in. So now when I instantiate this, so we call factory, and then I'm just going to call create, and it's called 1+. And so this is the brand I want. I want a 1+. And then I'm going to sit there and say I want the color white. When we go into this, it's going to take the brand and it's going to basically switch or figure out which constructor to call. So it's going to switch to brand to 1+. Here it is. It's okay. It's going to pass in the color. The color is an argument that was actually passed in through the factory. And then it's going to make here, it's effectively a default. So if you have some parameters here, like the amount of memory, well, maybe it's just hardwired, like, okay, this phone only gives you 256 gigs of RAM. You can sit there and you can set additional parameters in here, so you can put more settings in here, as you, autocomplete, as you need. And the customer just needs high level switches, right? So this high level command. So like, think about when you're buying a car, you just sit there saying, okay, you go to a dealership, you go to Volkswagen, you go to, I don't know, BMW, Honda, whatever. So you go to that company, and now you're going to basically say, I want a Honda Civic. Well, that would be your brand. Well, what color do you want? I want a white one. Well, what trim package do you want? Oh, I want the GT trim package. And then that would basically delegate into how it's actually going to communicate to actual manufacturing of it. And so this might set more parameters, additional parameters, but the customer just set 2 or 3 parameters and it can expand. Now, one approach is we can just set the parameters, right, directly. So every single parameter that the object has, so like here for the phone, every single parameter we can expose up to the factory. And then it becomes one-to-one. At that point here, your factory create function has every single parameter as your constructor, and it's not really encapsulating, it's not really protecting you, it's not really delegating the work for you that much, because you would have to have, as a customer to the factory, you have to have complete knowledge of the interface of the phone. So what you can do in the factory is simplify it, reduce it. So in this case here, I just went brand and color, and just by picking which brand, there are some decisions made for us. So in this case here, let's say iPhone, I have iPhone and I have iPhone SE. So the iPhone, the standard iPhone comes with 256 gigabytes, and it's going to use the standard body. So these are 2 parameters that are just tied into the fact that if I want this type of phone, and these parameters are actually passed down into the constructor. Where if I pick the SE, I'll get less RAM and I'll get a smaller body. So what I'm trying to get and communicate here is that the factory doesn't need to be one-to-one with the parameters that are passed. It's going to turn around and delegate you a solution. And one of the problems with this is you almost, like with a factory, you almost need to have you start creating it traditionally by using constructors. Then after the fact, you add this form in pattern on top of it to clean up your code, to start abstracting this, where now the client doesn't have to know as much. So when you're first probably roughing this system out, you might literally start practicing and developing it with, full parameters. Um, and then you would pass in the color. Well, what's going on? You would pass it in with color. Color, there we go. Color dot, we'll pick red. And then your memory, let's say here's, 256. Then your body style, and so this would be under iPhone. Body. And then you're saying, okay, I want a standard. And you would start doing this and you start to realize, like, over time, you're doing a lot of cut and paste. You're starting to realize, you're starting to see a pattern that there's a lot of parameters that are in common. So you sit there saying, you know what, I want to have a factory, and they have the factory kind of encapsulate and wrap a lot of that complexity there, so I can sit there and call things in high level. Now, why is this useful for us? We're going to eventually start creating aliens for the Space Invaders project. So, we have here is the display, and we'll have up here, green aliens. Right, and then we'll have, squids. And then jumping jack guys, or crabs. And when we're creating this, we're going to have to create many of these, so we have to sit there and think about this. There's going to be 11 across. So 11, and there'd be 2 rows of greens, and then there's, another row of that, and then the squid, and then so there's 5 rows, 11 individual elements per row. And so all these guys here are basically, they're different objects. They have different sprites, they have different collision boxes, they have different behaviors, they have different points. So they have a lot of different things. So they're actually a different game object. So we have a game object. If I can get this thing going, there we go. So we have a game object. And then we have here would be the squid, and then I'm sorry, this is a squid. Crab. Octopus. Right? And so these are all going to have different behaviors and different data, but they're all game objects. So we can have the factory you pass in a parameter like create a crab, and it's going to generate a crab and then return a crab to us. So in this case here, we would get crab. Gets returned. So now we can start to say have our factory start doing this. Well, then if you go a little further, when you start dealing with the factories to the next level, you want to make a grid. So you might have for loops, And now you start seeing, okay, this is my, this is my X position. And so you do the factory, and then it has a certain X position that's driven, and then you're going to sit there, say, for a certain row. Yeah, row. Oops. Crab. And now you can loop through there and create, boom, 11 crabs at a certain row. And then you're like, oh, wait a minute, I can sit there and do the same thing here with a different row and do the octopus. And now, okay, that create. Now I can sit there in a loop and quickly and almost uniformly create my 55 aliens. And all I have is one factory call per row, and then I iterate, here I iterate per column. And now I suddenly create 55, and I just have a small little for loop, and it's creating my whole grid of aliens. So that would turn around and generate all these guys here. So the factory is useful. It's a way to create objects very cleanly, and you can encapsulate and hide things away. But off the bat, from a runtime perspective, there's one thing that's kind of a little bit cumbersome, right? As your factories get more and more complicated, and it's pretty typical. People generally, are going to switch off of some parameter, or groups or parameters, or conditionals. The switch statement gives us some trouble, right? And if we actually have every single enumerated parameter, so here's the brand. So if we have all these things listed and they're enumerated, the compiler can actually do a jump table and just hop down to the right element. If this is sparse or not contiguous, right? So like if you sit there and say, I want my enumeration to equal 3, and the next one to equal, 17, and the next one, equals, 400. And so all these numbers are disconnected, not continuous. Well, then the switch statement kind of goes into a crappy scenario. It goes into if, else if, else if, else if, else if, and then we get to default is else. And right now, we have like 7 or 8 of these. It's not that bad. You're going through 7 of these, but as your cases increases, that's a lot of else ifs and else ifs. And so we'll see next week, we're going to be talking about double dispatch in the visitor pattern, and we can replace the switch statement completely with double dispatch. And then when it just turns out to be jump to one class, turn around, get redirected to another class, it's 2 hops and you're there, whether there's 3 items in your case statements or there's 3,000, it's only 2 hop and you get to the answer. So we'll switch this statement, we'll switch the switch statement next week and enhance this better and to make this double dispatch. And that's going to kind of clean this up a little bit more. So, we can pass in parameters. We can have defaulted parameters. We can add logic in here in the creation. Once these phones are created, if we wanted to, in our case for the game, once we create these aliens, well, we might want to add it to a game manager. So we can actually add it right here. Is right before it leaves the door, we can sit there and say add to manager. So not only do you create the object, but you can do game manager dot attach, and then you can attach your in this case your phone. So we can have additional logic here. So this is a pinch off point on creation, and we can associate things into containers and into lists at this stage. And what's nice is the calling function is pretty straightforward. We just do this. Can even just, we don't even need to return. If we're going to be throwing these in the managers, we don't even need to return the handle to these things. We can just have it sit in the manager. So that's kind of, to go back to the programming assignment we have, that's a little bit, kind of, hopefully that kind of clarifies a little bit and helps you with the programming assignment. So you can see here, the programming assignment has the factory creates cars. And so we have cars, here's Volkswagen kind of fleet. So we have Atlas, Tiguan, Golf, and Jetta. And they have different capabilities. Some have a sedan, some are 2 doors, 4 doors. They have color, they have different engines. And what we can do with this factory then is just create the car. So we see this here in the unit test. Here we create a factory. Then we call the factory and create like a Golf with the car. Then inside of this, it's going to expand or associate certain parameters. So if we look at the Atlas, here's the constructor that we need to match: doors, color, and engine. But when we look in the tests, there's passing in model and color. So we're going to have to make some decisions on which engine and which package gets which engine and how many doors actually get passed in the constructor. So we can kind of encapsulate that into the factory itself. So questions?
Are there any scenarios where the enums, enumerators that are passed into the factory have like a none?
Yes, you can do that, yeah. And the other thing with the factories is you can I don't, like the factories are there for cleaning stuff up and organizing, right? And one of the things you can do with the factories is you can put, I guess, checks and balances, or like rules saying like, wow, you picked a 2-door on a vehicle that doesn't exist. Well, you can do an error checking in there and somehow return an error. You can consolidate that. There was a thread on Piazza, which is really cool. People say, we can just have a default. We can say, this equals, 4 doors, right? So we can have it, as a default parameter. And that's one approach. I kind of like to set the parameters in the factory. And the reason why I like that is when you deal with defaults, right? So like here, let's look at my phone. So we'll do Pixel Pro, right? So when we go to Pixel Pro, it goes Pixel Pro, and it goes down here, and it says Pixel Pro, and it goes, okay, this much memory, and this is the body style. I could have defaulted my memory to be 512. Well, then I would have to go into the Pixel constructor and look and say, what's your default memory, right? And then, okay, so now it's 512. Okay, that's cool. Now, what happens when we go to the standard Pixel? Well, it's not 512, so now I have to overwrite it to and actually specify the parameter. And because sometimes I have to override it, sometimes I don't, I rather have full knowledge at the factory level that I know what settings I'm setting. So so that's kind of why I like that. Did that answer your question?
I think so.
Okay. All right. All right. So does this clarify there? So here's 2 things I'm doing a little bit new with this term, or this version of SE456. I'm giving you a unit test, right? Which I never gave before, and that's why it's cost me 1,000 hours to figure out how to write unit tests for this stuff. But what I'm realizing there is that I show you the code, I talk about the pattern, but I think there's one more layer that is missing that to kind of I want to say, I think people are having a hard time jumping from this. And I just took this for granted, I think. But when I show you the pattern by the slides, right? This means a lot to me, this diagram right here. So going from UML to code, you know, that's what you're, you want to get out of this material. You look at this UML and going, okay, here's a framework, and here's the product, and then you're going to basically have the factory create new objects and hand it to the client. And so here's the actual design pattern, which is you have your factory, and it could have base objects. You're going to create it, and then you're going to return a product. And that product is going to be a family of products. So there's, a car, and then there's many different types of car, or phone, and many different types of phone. And I think what's missing right now to help the class a little better is, from this standpoint, this tells me 1,000 things right now, right? But I don't think it's as obvious. So what I'm trying to do now is trying to give you a simple sandbox of a really, really generic pattern that you can see. So like here's a phone, you can see it. And then you can actually see how it's called. And then you can see that it lands at a layer. And then there's the switch statement, and it adds extra parameters, and it returns the object. I think that little extra might help. I don't know. What do you guys think?
I feel like the first programming assignment was kind of like copy and paste from the lecture, versus the number 2 was like actual problem solving.
Right. And the catch here is copy and paste. It's like there's different ways to learn, right? One is you mimic. The second is you kind of explore on your own. The third one, you kind of go without a safety line, right? And so some people need a lot more examples. Some people, I want to go it my alone. So I have a very different audience here, depending on your experience, right? After this class, you're going to have pretty standard experience, and then subsequent classes will be, running really quickly with just UMLs. But so the idea of these the unit tests here is to really, really tear in and to beat up the pattern. So we really have an inherent feel for how the pattern really works. So like the adapter pattern, the iterator pattern, basically you're going to make an iterator. In this case, here's the linked list. You're going to start from the head, and you go all the way through, and you're using the forward iterator. Well, the base iterator has current, first, is done, and next. And the unit tests, and also, if you kind of go deeper into this, it's kind of hitting you, what is a current? It returns your current node. You can call this 700 times, it's going to still return the same node. It's only when you call next that it's going to advance, right? No matter what, you can have your first, you have your first thing. This doesn't move after it's initialized and it's set to first. You get to first. What happens when there's no items to walk? How does these things default? What should they be? So these are the questions I'm trying to tease through. And so the iterator kind of is going to hit home a little bit more to make sure we really understand how the pattern is. Once we understand the pattern, then when you look at my sample stuff, the rapid prototype I'm doing in the game, just throwing things together, you can see, oh, Ed did that wrong, or I like this way, I'm going to rechange it to this type of singleton. And now you're putting your mark on it, your fingerprint on it, your preferences, so like the factory, factory pattern, there's 2 styles of factories, right? So the first style is it returns a get instance. And if you look in the book, that's kind of how it's done, get instance. And if you look in the code, it says singleton get instance, you get a pointer to it. And then from that point on, you can just start using the pointer, right? Pretty easy. The other approach is never give them the instance, never give them a pointer back. So I hide it. So if you say global manager, well, internally, this has to be a static method that internally gets a get instance, right? And I like this a lot more for our managers because I don't want to be passing around, manager as a two-step process, get instance, check the instance pointer. Is that okay now? Dot add. I like to kind of have that all privately encapsulated into a static methods. So these are two different styles. Now in your application for Space Invaders, you can use either, right? But I feel like the unit test is something there to kind of have you explore forcibly into some of these different ideas about these patterns. At least that's the thought, maybe. Does that make sense?
Yep.
All right. Okay, so let's keep going. There's just a lot. So one of the things I have here is what we're going to do. This class is we're going to make Space Invaders from scratch, right? And we're at the beginning phases of the stuff. Stuff's going to come together very quickly moving forward. So the catch here is you got to kind of hop on this train and keep going. I was in this one class when I was an undergrad, and it was a circuit analysis, right? And this class killed 70% of the people failed the class, and there was 3,000 students, and you couldn't go to the next class until you passed this class, right? And the teacher said this one thing, and it stuck with me, even 30 years later. He said, the class is a slow moving train. If you're ever seeing a train up close, they move kind of slow, right? And you can kind of run along it, the big heavy freight trains, and you can run along it. But if you stop and tie your shoe, the train is moving a little bit further. So now you have to sprint to catch up to it. But if you lay down and take a nap, well, by the time you wake up, that train is in a whole nother town and it's way far away from you. If you wait for 2-3 days, it's in a different state. That's the idea with this class, is that you have to keep up with this, otherwise the train will drift away and it's going to be almost impossible to come back after it. And so with that said, it's very obvious to me kind of where you're at from the sprints. So the sprints are there to kind of push you, to keep you on top of this. I want to see multiple check-ins for every sprint. That is being totally graded. That if I don't see multiple check-ins, I assume the worst, right? You can do multiple check-ins in one day, over 6 hours. You're like, when I check this in, then a couple more hours I check this in, check that in. I want to see multiple things so I can see your development and kind of see where you're struggling on this stuff. So I have analysis tools to kind of look through this stuff. So please do a lot of check-ins and try to apply the sprint. So the first couple of sprints are going to mimic my code very tightly, but you have latitude to start shifting things. I want you to use the patterns, but how do you use the patterns, what format that methods I'm calling and what you want to call, you have some, you have a complete discretion in how you want to deal with it. But I don't want is you not to use a pattern. We can make Space Invaders in one weekend with a big honking for loop. It will work and it will look great. That's not the purpose of this class. The purpose of class is to use factories, and we just happen to be doing it on top of Space Invaders. So it's kind of a reminder there. All right. So all right, so let's look at so last week we did box sprite, and basically box sprite is we just shake and bake and repeated the sprite, and the sprite should look the same as what's the word I'm looking for? It's the same as in other sprites, but now we have boxes. So then because we have it as a monolithic homogeneous manager, we need a box sprite manager, right? Which isn't that bad, but what we're going to have here is now sprite, and so we have a sprite box manager. And if you can see here in the game, we have create a sprite box manager, and then down here is create, here's sprites, create a box sprite, some with colors, some without, and then add them to the manager, right? And because we don't have it integrated at this stage here, we're going to call manually on the sprite box somewhere here. Yeah, sprite box here. We're going to swap the colors. We're going to call our own update. But because we don't have it integrated into the sprite batch manager yet, we're going to have to call render ourselves. So we call render, right? So then moving forward from there, the problem is we now need to deal with our sprite batch. And our sprite batch, what we want to do is we have our sprite batch here that is manager. We're going to have sprite batch A, sprite batch B, sprite batch C, and then these will have multiple sprites. Right, and the whole idea is that sprite A gets drawn first in all of its respective sprites. Then sprite batch B goes there in their perspective in C. So it's like groupings or binning or batching between these. And how we did this in the sprite batch managers, we had to make a manager of managers, right? So so in the first level, that's a manager, right? But then when we look at it down here, that's a manager. So we have a manager of managers. And so that's where we have the little more complexity that we're talking about from last week. Thought we had it. Yeah. So I had a really pretty picture, I guess. Yeah. So here's the shows me I had to label these better. Yeah, I think it's 74. Okay, there we go. There it is. So sprite batch manager is a manager of managers. So this is the first one, and then this is the second one, right? And so that's a critical kind of idea, is that we're having that, right? So then how it deals with this is that we really have, conceptually, we have here a sprite manager, and then this owns sprites. And so at any time, there's only one ownership of a sprite, but then the sprite batch will have say three batches, and then this is going to have the associated nodes. Right, and then on one node, it's going to have a pointer to a sprite. So let's say this is sprite A, and this is batch ghost. So it points to this. Well, so there's always these guys are all pointing to the respective real sprites. So we have this idea, is that a node points to here we'll just sprite node points to this real sprite, but the sprite is owned by the manager. And so at any time, there's really only one owner of the object. But we can have many, we can have many guys point to them, but there's only one owner that's a solid black diamond. And this ownership is really important. Right. All right, so then the last little bit here is, well, this is cool. We have sprites, but now we have this. We have sprites, and then we have box sprites. So, here we have multiple box sprites, and we have multiple sprites. But what if we wanted to have a single batch, right? These are nodes, and they point to, so now within one batch, we have actually a collection of sprites or sprite boxes in one batch, right? And this is not homogeneous. So the solution there is what we did is we had a sprite node points to a sprite base. And then from there, we have a sprite and a box sprite. And now, since all we're doing with the sprites thing is we're going to sit there and say render. So we're overloading a render. So then we're going to have an abstract render here. Then we're going to have the overloaded here. Make this a drop. Okay. So the whole reason why we added a sprite base is so that we can have mixture of sprites and box sprites in the same sprite batch. And we just say draw, and it goes, oh, draw, and it goes Duke, which then will call the right draw. Or if it was the other guy, it will Duke, and then calls the right draw. So that was the whole purpose of the sprite batch. Sprite base was to abstract different sizes and different shape objects, and we just connected by the header base class. Does that make sense?
Yep.
Right. So now down here, when we look at the sprite batch, go down here, the sprite batch node right here, this last thing will be connected now to a sprite base, and then from there it connects to the appropriate either sprite or box sprite. Okay, and so now what this means is we can just basically draw anything on a sprite batch. We can mix and match it. So the artifacts look the same. Structurally, it's very different underneath the hood. Right. So you can see, the aliens are drawn and there's the boxes. And now in the code, there you go, code. Pac-Man, Angry Birds boxes, we just add them all together, we attach them, and we can mix and match in here. We can sit there and say, you know what, I want to attach these to the box one. So we can have the boxes being both a mixture of sprites and sprite boxes, right? And my print statement's bad. So as soon as you start mixing things up, print statement's bad. Okay. Sometimes the print statement is like the hardest part, but we can see it all works, right? So
Could you show
explore.
us in that running game, like a box, like where like would those ghosts be in boxes?
No, everything is a drawable item. A sprite is a drawable picture that you put on the screen,
Mm.
right?
Yeah.
So in this case here, we have 2 boxes in Greenberg's. They're in the batch called boxes.
Oh, okay.
Yeah, sprite. And so I was getting tired of typing P sprite batch boxes. I just said SB for sprite batch. So here's the sprite batch, being created.
Okay, thank you.
So what we could do is this. Let me just change this in 2 seconds and show you. We just call this group A, right? And now, boom, group A, and then this will be group A, and now I'm just going to get rid of these. There you go. That's in one batch. Does that make more sense? And the reason why this works is we have sprite node here. We have sprite node pointing to a sprite base, and the sprite base has both, a lot of fields for sprite, less fields for box, and then, but they have the contract render, and the render is overloaded here, and render is overloaded here. So when we call on this and we say, all methods, sprite node, so we can sit there and grab a sprite node, go to the base, and then call render. So we're doing that here in the draw. Sprite batch draw goes to here, and what it's going to do is grab the iterator. So now we're going to walk through each of the batches. So each of those groups, once we're in one group, we're going to sit there and say, okay, hey, sprite node manager draw. So we're not going to sit there and iterate inside of the bucket. We're just going to kick the can. So now this goes down to the sprite node manager, and then calls its draw, and this goes, hey, I got an iterator within one sprite node manager. So then it'll iterate through this and it call render. And this is right here where it's going to do the delegation and push it down through. So that's where it calls that, which will then we'll call the respective render depending on which guy it's, sprite or sprite box. Does that make sense?
Remind me again why sprite box doesn't have a P image.
It's the wireframe. It's the wire.
Oh, it's okay. Thank you.
So it's literally, see how it is? It's just a wire.
So that's the P box. Okay, I'm using sprite box. Okay.
Yeah, that's a sprite box, right? Just the white box.
Thank you.
And the
that's
reason
what I meant by like, which one is it on the screen? And you...
Okay, yeah. It's just a box. And the reason for this is we might have, aliens, right? And then it goes to the collision boxes, right? So this is the sprite batch manager. Right, and so the aliens, here's the aliens, right? And then here's the boxes. Okay, and so what this means on the screen, and if you haven't played Space Invaders, download a copy or go to a website and start playing it, because you're gonna have to get comfortable with it. So so the aliens here might be this. Here's the alien. right? And so this is, A, B, C, A, B, and C. Okay. And then we'll have the collision boxes. Because really, we're just painting pretty pictures on it, but we're really colliding the boxes. And these are the boxes. So that's A, B, and C, right? So you're like, okay, so I draw all the aliens and I draw the boxes, right? But then we can sit there and say, turn it off. And what we just do is just go to here and go, it's off, skip it and go to the next thing, draw the shields, right? And suddenly it's as if I did this. Oops. By skipping that, just by skipping that bucket, they don't exist. Then if I turn the bucket back on, saying draw this.
Does that say shield after collision
Yeah.
boxes? Okay.
But these are collections. We can have shields, players, score. You know what I mean? It's a collection of collections, right? Collection of sprites. So now, if we turn that on, boom, the boxes come back. So now we can toggle boxes on and off. And you're for sure like going, big deal. I can just put a flag saying skip, draw, skip, draw, skip, draw. Well, when you have 700 boxes on the screen, and you're like, I just want the boxes of the shield to be on and not the boxes of the aliens. Now you want to start categorizing this. And you don't want to sit there and touch every single item. You want to sit there and say, skip this whole collection. So yeah, let me see if it's here. Let's see. Yeah, I showed you a demo of a previous student, right? When we started the class.
Yeah.
And he could toggle the boxes on and off. I have to dig that up. I thought I demonstrated this. Now I don't know where I put it. Anyway, I'll demonstrate it again next week. But basically, you toggle the boxes on and off, and you can do that by doing the collection. And when you start looking at the game, there's gonna be thousands and thousands of I know where it is. No, wrong button.
And then the straight shot that all fall.
Did you intend to mute it?
Yeah, I intend to mute it because it's not material. See if I can. Where is it? Big. That's right.
Is that the same video you showed the first class?
First class, right? Basically, you're
Okay.
toggling the boxes on and off.
Okay. If you could share that link, that would be great because it was kind of blurry in the YouTube when the lecture came out. It was really hard to see.
Yeah.
But this looks really crisp.
Yeah, well, I'm not in France. So I think it's getting choked. See. I have another student, but I'm sure Bob, come on, Bob, show me this. I don't think you showed it. Anyway, I'll get you something to show it. Yeah. Anyway, it's just we're toggling. So every single character that's on the screen, there's a lot of them. There's many aliens, right? And imagine a box around each guy, and then there's a lot of little boxes inside of here. There's a box for this, a box for the screen, and you want the game is really just boxes versus boxes, and this you paint these pictures on it to make it look pretty. So that's what we're doing. Do that. All right, so let's keep on going. This is how I get lost in the woods. All right. All right, so okay, the next thing we're going to get into is the timer, and the timer what we're going to do is basically do a priority queue, and we went through this a little bit last week, but a priority queue is just simply a you put objects onto a list and you give it a key or a priority, right? And when you have these on the list by key, you're going to take your new one. So let's say here's a new one, and it has a key, and you're going to insert this on the list based off of its, in this case here, it's time. Like, oh, it goes here. Oops, let me just shrink this. And boop, you'll go right there. And then we'll get another one. It's like, oh, does it go here, here, here? No, it goes right there. It goes at the end. And you're going to basically insert items onto a linked list or a list of any sort by a key or priority. And that's all a priority queue is. It's just the ability to have a list that you insert by the priority. So what we're going to do is we're going to have a timer. And the timer is going to have on this list time events. And so we multiple time events. And it's going to have two different things in there. It's going to have the trigger time. And it's going to have the delta time. Okay. And so basically what you're going to do is you're going to put everything by this trigger time. So you'll have a certain time, certain time, certain time, a certain time. And so if you insert a new one here, and it's, let's say it's 300, and this is 100, 100, 200, 300. Make my life easier, 400. We're just going to insert it like, no, it will put it, okay, it goes in there. Then let's say you have another one, another time event, and it's, the time is 150. Like, okay, where does this go? Let's go, blah, 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 it goes right here. So
I have a question. What do you mean by time? Is that like the time it's supposed to take to execute or something, or
it's a trigger time.
it happened?
We're going to get into that, but the time's going to be this. It's going to be, what time do you want me to trigger this? So let's say here, it's an alarm clock. It's an alarm clock. That's probably a better way to think.
Oh, okay.
So I want an alarm clock at 5 p.m., 5:30, and 7, right?
Mhm.
And then somebody goes, hey, I want you to add an alarm clock at 9. Like, oh, it goes at the end of the list. I want you to alarm clock at 1 a.m. It goes in the beginning of the list. Just put it is inserted into sorted order, right? And so that's what we're gonna have is we have a timer. And what's gonna happen with the timer is every time through the game or through the loop, it's gonna say update the time. So we're gonna have, skip this delta. That was premature for me to say that. So we have this time, right? This is the trigger time. So we go start a game. Our time is, so off of this, we have the permanent time. Our time is 0. Okay, cool. And the game runs through and we go back to the update. We say update the timer. It goes, all right, we say get the time. It goes, hey, my time now is 10. So we're like, okay, cool. We go, nope, it's 10. And we look through the list. Is this 10 or less? You know, I mean, is this timer equal to or less than 10? No. Okay, going back and nothing to trigger. So we have an update. We have a set time, right? And we keep the persistent time. So in our game, game.update, you know, in this function, we're going to do timer, you know, manager that, you know, that update. And there we're going to pass in the current time. So when first time we go through this, you know, we initialize this and it says the current time is, you know, the first time is 0. And it goes through some things, it goes back, comes back around here. It goes, what time is it? Well, now it's 10. And then it goes, executes things, come back around. What time is it? Now it's 20, right? Keeps going. And then at some point, we'll have this. It's 101. So we go, okay, go through and list. Hey, this is less than 101. You know, call this, right? Right? We call it and we remove it. We go like, this is less than 101. Call it and then remove it. This is, oh, this is greater than 101. Stop. And then it keeps updating 105, 110. Then all of a sudden it goes to, you know, 203. Okay, cool. 203. Oh, trigger this one and then trigger this one. So we keep doing this, and once we do it, remove it off the list. So it's just, it's a time event. So it's like I have a timer. When the timer hits or it's passed, do the event. We're gonna have this on a linked list, and we're gonna always insert into the correct order based off its time. So that's the idea of it. Does this make sense so far? To do this, we need to have.
So would you, so you have all these things like predetermined on the list, preloaded, or?
Some are preloaded, some are going to be adaptive loaded.
Yeah, so it's like something, okay, yeah.
Okay, so I'll give you an example of this, right? You have, here's your alien, right? And it has a collision box. Here's your missile coming up at it, right? Do they hit? No, they don't hit. But then the next frame over, oops, you know, a little bit of delay, and then we look at the game right now, and it's like here, here's our alien. And then we like, wow, look, the collision box hits, right? The missile hit. We'll keep this green.
Will there ever be matching times like other timer events that have the same time? Yeah.
Yeah, and you just trigger them all. If
Okay,
there's a
thanks.
tie, you just trigger. There could be 17 timers at 15 seconds. You know, then you trigger all 17. It's like, think about it. If you set up 5 alarms saying, oh, I want an alarm on February 10th. And then you sit there, it's like going, I want an alarm on February 10th. I want another alarm on February 10th. When February 10th comes, you should get 3, 4, 5 alarms. That's okay. So let's say here, the missile moves up, right? It hits an alien. What happens to the alien, right? Alien disappears, right? So this disappears. And this disappears because it's a collision, right? Then what happens? Well, then you get this thing called splat. So it's like, you know, let's show that something happens with the splat up there. We put a splat, right? But we don't put the splat up there in one frame. We keep it there for, let's say, 0.5 seconds. Then what happens after 0.5 seconds? It goes away, right? So here's your timer. Your timer has just tons of timers, you know, time events on there. Ding, 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 ding. You're like going, collision just happened, right? You go, okay, draw the splat. So you go, okay, well, here's the splat.
So it was like kind of part of it is like you know that event's about to happen, so you add it, and then you know it's
No,
gonna happen
when
every
the
time, or
when the event happens, you add it.
Okay.
Right. But then okay, so that's cool. We draw it. So the first thing it goes, it's current time. So you go, current time. This is, let's just say when this thing collided, t equals 150. It's like t equals 150. And you're like, oop, draw it. Boom, it draws. So now we're in this state, right? But you're like going, I want a half second later, remove. So you add t, let's make it 1 second. Let's say, let's just for sake of argument here, let's say that 10 seconds later, it's deleted, right? 10 seconds later. So we sit there and say, add a, at 160, add a remove splat, right? So now the game's just going, it's like draw. Okay, that's drawn and that's off the list. Now it's 151, 152, 153, 160. Now delete the splat. You see how it's like it's going to pull things off and then delete it. Don't worry, we'll get there, right? All right. So one of the things we want to do is we want to have action to happen on this event, and so we're going to do that by using this thing called the command pattern. And the command pattern, now here's the command pattern. It's a pattern that encapsulates a pattern that encapsulates the a certain request, right? So here's the pattern, which is basically command, and it has a abstract method called execute. And your concrete, you implement execute, and it's going to do action onto the receiver, right? So this is a command, and basically what it is this little request that's encapsulated in an object. You can pass the request around, you can attach that request to a linked list, you can do anything with the request, right? That's your little, like, you know, I want, when something happens, I want you to do this action, right? And so, you know, here we just have the base has to execute, the drive object will then implement execute, and it has to do its work on somebody else. It's going to call somebody's method, somebody's update, somebody's action, right? So let's look at that. So here's command pattern. All right, so the command pattern basically encapsulates a request and we call it, but we have to associate in receiver. So here we go. The design, yeah, there we go. So here's the pattern. So we're going to have basically a pattern that says jump. Right? I mean, here's our command pattern. There you go. This says abstract execute, right? So it has an abstract execute. And then we want a command. So let's say a command is jump. So when you call execute for the jump command, you will jump, right? So the pattern is really simple, is that when we have the invoker, right? The invoker is one who's going to call the calls, right? So let's say we have on this invoker, think of this as your linked list holder, right? This linked list holder, you have a linked list of commands. So we have a linked list of commands. One command's called jump. Let me get rid of all this. We have one called jump, one called reset, right? Listen. All right, so here we go. Ignore all this. All right, we have a command, it has execute. Then we're going to basically implement execute in the jump command. So the execute will do a jump. Run command, the execute do a next run, or a reset command, the execute will do a reset. But for it to work, you need a receiver. So you see right here, you need this receiver, right? So it's going to do the action on the receiver. And so what we need is a receiver. So how do we do that? Well, let's go down. When we create the object, we're going to create we're going to create it, and we're going to pass in the receiver. So when the jump is created, we'll say, hey, and this is the guy who's going to receive the command to execute jump, right? So in our code, we basically create a receiver, and then we just sit there and say, you know what? Here's the so here's a receiver. We create a receiver and we say, hey, jump needs a receiver. Oh, here's the receiver. So now the receiver is associated to jump, right? Now we're going to put this command on some linked list or on some queue. So we're going to add it to the invoker. The invoker just holds the linked list, right? So it just has a pointer to a linked list of commands. So now we basically take the receiver, associate to the jump, then we're going to add it to an invoker, right? So just a holder. Then we'll say invoker, call the command, and the thing goes, okay, cool. I'll walk the linked list and call execute. And so what's happening is the invoker is going to call the command. The invoker is going to call the command, which is going to, it's going through linked list of this, it'll call the execute. And the execute will then call this thing and will execute on that receiver. There's the receiver. So, so remember, when we create this, you get all three of these are stacked. So when you instantiate jump, you get a command base and you get an S link, right? So here we go. We create the receiver, we associate it in the constructor to the jump. The jump constructor just associates that pointer and keeps it. Then that gets attached to the invoker. So we add jump. Jump goes, okay, here, add it to linked list. Then when we want to, we say, hey, invoker, call the commands. I'm like, cool, call it. And it goes, okay. It walks through linked list and says, call execute. And it calls execute at the command level. And then it goes, oh, it's overridden here. So now it calls this guy. Right. And now we can have the command. So now let's add some stuff back here. Now right? So now we have two commands. We have, maybe I'll just move this down here. We have the receiver. We created the receiver, and then we sit there say create a run and a jump. So those both take a receiver. So run takes in the receiver and associates the pointer. And then the jump does the same thing, takes the receiver and associates it. So now we create the invoker and we go add, run, add, jump, call commands. And the call commands now will go through and say, okay, call the first one, jump, and then call the next one, run. Okay. Now, what if we want to do an action on something, but we don't have the pointer to it, right? We don't have the pointer to it. Well, we could still have a command do an action onto somebody, but we don't necessarily need to pass in the pointer. So we can do this with static methods or singletons. So here we can sit there and say, when you call execute, it's a reset command. I want you to reset the hardware. The hardware has a singleton static method called reset. So hardware has a static method called reset. So you don't have to pass a pointer over to it. You can just call that directly. So now we have this. We have all the commands. We have a jump command. We have a run command. They both point to the same receiver. The receiver has a jump and a run. Then we have the reset command. It calls a static method on the hardware. So now we have three commands. Those all can be associated to a holder. In this case, it's the invoker. And now we can call jump, we add all of them to call commands. So here.
Was the receiver the one that had the static classes for jump and?
No, only the hardware.
Okay, thanks.
So you can see right here when we create it, the jump has a receiver as an argument. The reset command doesn't. So now we go into the call commands. We go into this and it goes, okay, give me the first one. Boom, now call execute, and it jumps into the reset command. Reset. Then it goes, okay, next. Go to the jump, call receiver's jump. And now go into the receiver's run, do the run command. Now we're out of commands. And you can see there it is. There it is. Hardware was called, the jump was called, and that's called. So a command is just a contract. It has a base class, and it has an execute, right? So let me just kind of reduce this. You can generally commands will point to it has to have a pointer or some connection to a receiver, right? We need to have a way to find that receiver. You can call a singleton, say, give me the receiver. You can sit there and call a, you can pass it in as an argument. You have to somehow get your hands on who's going to do the function, right? The base contract just has an abstract to execute, and then it's overloaded, overridden here in the drive class. And that's it. So you'll see this pattern 100 times, which is contract. And if you want to force a contract, you make it abstract. It's a method. And then the concrete class will overload the method. And so that's kind of the pattern here. In this case here, this is typically called execute. and you're going to, inside of execute, you're going to do action on a receiver. Here's this jump command. So you're going to be basically calling the jump command. So why did I go through this contract? I mean, this command pattern. We can have the command pattern be with direct receivers. We can even get it a little more elaborate where it can, it doesn't need to actually have a pointer to the receiver. It can call some singleton or some static method and call it directly. This is going to be our timer. So our timer is going to now do some action. And the action is going to be a command pattern, right? So let's take a look at this. Right, so we have the timer. So we're going to create a timer class. We're going to create a timer manager. We're going to sit there and drive from man base, the whole spiel, right? So here's timer. The timer is going to drive from man base, and man base has list manager, dealing, timer event. Here we go, timer event. So timer event, right? Basically, it's going to say it will have a pointer to the command. Why does it have a pointer to the command? Well, because the commands will have different sizes, different shapes. So here's a simple command that has one pointer. Here's a repeat command that has 2 data fields, right? Because they're different size, number of arguments, different variables of arguments, and different shapes. I call it, like this might have the same 5 fields. This has 5 fields, but they have different variables or to mean different things. So that's shape. Size is number of variables or number of bytes. So since it has different size and shape, we can't do inheritance off a timer event. So we basically do aggregation where we point to it, and this command now behaves as if it's the sprite base. The same pattern we used before, sprite base. Here, and then we do this, remove that. Okay. Now, I wanted to show you guys one thing. I do a lot of prototyping in this command, this diagram stuff, right? And, I do everything from here and I just double click and it jumps me right to that code. I go back to the diagram. If I want to sit there and say, where's this execute method? Double click and go right to it. Where's this variable? P receiver right here. Or if it's not in there, you can go into shows field. And now here it is in the field, and you can just double click and go right to it, right? So this diagram is really nice from that standpoint. But here's another thing I found that you can do. This says command base right here. In our code, you don't see command base, but you see in the invoker, I'll get there. It says command base, right? So we have this word command base a couple times. It's also in when we do run, it drives command base, right? So it's all over the place, right? And this thing compiles. If I go in here and I just change it, oops, and I just change it, right? Now it just changed it everywhere in the whole damn application. So now if I go into run command, it's command with no space. If I go in my invoker, it's looping with the command no space. Add, it takes command no space. So suddenly there's some power in this, right? Not only can we quickly prototype connections, we can also refactor names. I don't like the word jump command. I want to call it, ostrich. Now it's called ostrich. And now I go to program, here's ostrich. So it's kind of cool that you can rename variables and it will chase it through the whole program through the command diagram. I don't know if you guys seen that, but start embracing this. Somebody said I didn't, there's a couple of things where people said I didn't understand how to use this. Just click and then right click and say shows field. Okay, got it. Shows association, got it. Let's say here, remove diagram. Diagram, right? You can say here, show show drive class, boom, show drive class, boom, right? It'll draw them all out. Now you have this. You know, sometimes you can't get wires to everything, but let's say you start with the command. Let's say command, you go, okay, show base class, expand, right? Here's S-link, expand there. Right now, P receiver, right click, boom, right? So you can quickly navigate pretty easily with this this diagram, and I really encourage you to start exploring that. All right, so where was I? Oh, timer. Okay, so now we have the timer, and the timer is going to connect to a command. The command will have the exe, right? So what I'm going to do, I'm going to have my timer manager, which has all this mess, go to a timer event. The timer event points to a command. The command, in this case here, I have a sample command, and it's just going to sit there and say, just print the current time. Ding, 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 ding. And so let's look at this here. All right, here's a command, command A. Command B, C, right? And a repeat command. Okay. And so here's my commands. And let's just skip the repeat for now. Right. What I'm going to do is load it up. I'm going to load it up to my timer manager. I'm going to say add timer event. I gave myself some names. You know, some names. And I'm going to say, okay, here's my command A1, here's my command 2 and 3, and here's the time that's triggered. So this is the trigger time. So delta time to trigger. So delta time to trigger. So this is what time from now to trigger. Trigger in 3 seconds from now, 3 minutes from now, 3 hours from now. But it's from now, not from the beginning of the application, but from now. It's delta. Right. So I create the command. Right, so it gets commands, I add it to the timer, and then I put a print statement just to show it off. All right, so here's my manager. My manager currently has 3 active nodes. The first active node is sample 1. The time to trigger is 3. The next sample is sample 1 name. Time to trigger is 2, and the next one is sample 1 is the name of the event, and it's time to trigger 1, right? And so that's just, you know, the time to trigger and the delta. So now let's look at here. At the beginning of your update loop, you're going to sit there and say, I want to update my manager. So you say update, get the time. So get the time is in a Zool function. It's going to return the time back in float. All right, so here's update. So update. First thing is it's a singleton, so get the instance. Now we have a handle to it. Now we sit there and say what the time that comes in, whatever time it is, let's say it's 5 seconds, becomes down the current time. Now we get the iterator to everything that's connected to the timer, and we say, okay, walk through the linked list. If my current time is greater than the trigger time, process it. And the process is basically going to grab the P command and call it execute. And here it's going to process the execute. with the delta time, right? So let's kind of see this in action, and then we'll go through it a little deeper.
Would something that's executed by the timer be considered something that changed dynamically?
Trying to change dynamically. What's changing dynamically? This is all it's executing, so it's running by code. Is that what you mean?
Yeah.
Yeah, it's not precompiled.
Okay.
Yeah, we're just registering it here. So okay, go through this thing. Let me turn off the print. This is getting so annoying. I always forget how to turn this off. I'll just reduce it into nothing. Okay. All right, so let's just do it here. This is 5, 10, 15, right? So now we're gonna look at the window on the side.
What are these numbers? Are they like seconds for Azul?
Yes, seconds. Yep.
Okay.
Seconds. Yeah. In other classes, I do different. So here it starts 5 seconds since it started. Boom. And then another 5 seconds. Here goes trigger B. Another 5 seconds. Here comes trigger C. Okay. And so what's happening is when we go through this, it's going through there. It says get the time, update it. So it goes into the timer, updates the time. It says, okay, here's my current time. Now go through the iteration. Who's on my linked list? If the timer is great enough, trigger it. So then we call process, and process is just going to basically call p command execute, right? And it's going to pass in, okay, if it was a repeat function, what's your delta time for repeat? So let's talk about the repeat. So right now I can sit there and create, right? So now I have 4 of these. So there's 4 that are happening at 5 seconds. 4 that are happening at 10 seconds. And maybe I'll remove one 10-second one there. These are just hop on a linked list. So you can add as many of these in there. You can have them equal at the same time. So now we look at the thing. It's like, okay, 5 seconds happens.
Okay, so it's like an asynchronous thing.
Yeah,
Okay.
this is your heartbeat for the whole system. And why is she not working?
Are they adding as a priority queue to the
Yeah, this is a
list?
priority. Yeah, this is priority queue. This is the priority queue. Oh, I know what I did wrong. It can't. These are all have to be unique instances. I can't have them all share the same instance. That's my mistake. All right. So let's do this. They all happen at 5 seconds. So when whoa. Okay. It's compiling right.
Is it because you have another event with the for the p command 3 with the same command?
Well, these are all different instances of the command.
You're talking about it says sample 1. Is that why? I mean,
Well, this is just a name.
okay.
Well, there's another piece,
Just
command 3 further
Dump
down.
is commented out.
Oh, yeah.
Yeah,
I'm
yeah,
sorry.
yeah.
Yeah. All right. That's my bad. Okay. Thank you. See, group debugging works. Or not. All right. So what did I foobar here?
Did you disable the update?
Is because timer event man dump is commented out at the bottom there.
This dump is, yeah, this is all right.
That's fine.
This ought to be out. All right, here, this will work. Let me put it back. Let's grow this out because then clearly I have a bug. So my code is just rapid developing, right? So All right, I really foobarred something.
Maybe double check you didn't get rid of the print.
Control Z. When in doubt, Control
Oh,
Z.
Like
Oh yeah, you did.
yeah,
that.
or this. Yeah, that would do it. Yeah, I mean, I don't even have to. That would clearly do it. I am surprised how many times I didn't even know I typed something wrong. Okay, so now this should all work. Okay,
This is the equivalent of, are you sure it's plugged in?
exactly. Is the cord connected to the wall? Yes, it is. Okay, so yeah, and this happens for a lot of times where I'm bouncing around and I accidentally fat fingered something. Okay, so this kind of gives you an idea. We can start doing this stuff here, but let's talk about the repeat, right? And this is an interesting kind of idea. Well, when you take something off the list, so when this thing is actually triggering, and I don't delete it, all right. So I have this updates, and it's going to go here. It says process. And then the very next line is going to say remove it from the list, right? So I call it once and I get rid of it off the list. So I call it and I exit off the list. It's off the list, right? But right before I leave the function, what if I add myself back onto it? So I can have this. I can have, here's my timer, and here's, oops, wanted to be orange. Here's the event. This happens at 5 seconds. So it goes to here and executes this. But then right before this, I go add it 5 seconds again. So now this thing gets removed, but I added myself back onto the list. So now this is at 10 seconds. And then when it gets executed, I add myself back on the list at 15, and then that gets removed. So what it is, right before I die, I add myself back on a list. I kind of re-add myself.
Wouldn't you need to add it after, or sorry, before? Yeah, no, after you've removed it from the front.
No, I add it before and then I remove it. I'll show you. It's a causal system. If you're worried about that, we're not like breaking time space continuum here. So, all right, let's look at this. Here's a repeat command, right? Repeat command. I'm gonna repeat every 2, right? I'm gonna add the repeat command. And it says, okay, when do I want the first one triggered? I want the first one triggered at 5 seconds. And then I wanted to repeat every 2 seconds after that. So 5 is the first trigger, then it's 7, then 2 seconds later, 9, right? So let's look at it. 5. Then every 2 seconds, it starts repeating, right? And what's happening in this command is when we get to this command, I have my repeats, so I keep my data for my repeats. I know what my repeat is. I turn around and say, okay, print the statement, then turn around and add this thing back to onto the list. So I just added right back on the list. So I call it. I'm actually in the execute. I add myself to the list again by a certain delta. Then I leave, and when I leave, that's when it does the remove. All right, so let's go through this. So here's my update. My update calls here. It sets the time. Now we have walk and link list to see anybody who's need to be triggered. Cool. I go to my process. It goes process. It goes execute, and the execute goes okay. Repeat timer. Where the hell are you? It goes okay. Execute. Print something cute on the screen. Add yourself back to the timer. Cool. And then I go back to remove. Now I removed the initial one off the list, but there's no. Yes.
Okay, so I guess what I'm confused about is so that inherits from a D-link, right? So you've modified the pointers and now you're removing it from the list after you've modified the pointers. That's what I don't get.
Oh, okay. I see what you're saying. The timer holds, and the key is the timer holds a node. That's unique. The timer points to the command. I'm inside the command.
Oh, okay, so the
So
timer
you get a new-
event is what's being removed. The
Right.
command is being re-added with a different new timer event to
Exact-
the timer event manager. Okay,
Yeah,
got it.
you're spot on. So I'm adding a new timer event. I'm not adding a new, I'm just reusing the command.
All right, that makes sense.
So with that said, then I should be able to add many of these like I was trying to do before I commented the stuff out. All right, so now we have this, we can mix and match this stuff, right? It doesn't matter because what's happening is, well, let me, let's do 10, 15, right? Now, first, I'm just going to do a dump to show you what's on the list. All right, so here's what's on the list. You know, we have a repeat that is happening at 5. We have a sample of 15, and they're in 10, and they're in 5. This is not a priority queue. This is just a stupid queue. You need to do the priority queue, insert in the sorted order. I just didn't do it for right now, but that'd be part of the sprint. They make sure you insert in the sorted order. All right, so you have these things on the queue. Then what's going to happen is when the 5 happens, this gets removed. When the 2 happens, that gets removed. When the 15 happens, that gets removed. When this happens, then it's going to turn around and add itself back onto the list. So this list keeps, you know, remove 1, add 1, remove 1, add 1, remove 1, add 1. So let's see. So there's first one, and then repeat command B, repeat command, and C. And then it's just, we're stuck with the rest of the repeat commands. You can kind of see it now. You just, this whole timer is the heartbeat for the whole game. This is the one thing that's synchronized, is the one thing that's everything's in lockstep, right? So where we're going from this is now, what can we do with this timer? Now we got a hammer. Let's look for nails, right? So let's animate a texture, right? Let's animate a sprite. And so, all right, so we have a sprite. Right, and it points to it points to an image. Right, so somebody kind of basically goes, hey, draw. And he goes, okay. It calls its render. And whatever is on the image, it paints. So if this guy is one of these aliens on your screen, you get one of those aliens, right? But I just stamp. I just always call them render, right? So when I drive home, you know, and try to drive home to my house, right? I've done it in my sleep. I've done it when I'm really tired. You know, I've done it, you know, I've driven to my house so many times, right? That if somebody's parked in front of my house, I will know that when it happens, when my airbags go off and I hit the car, right? Because I don't even look, I just jam it in there, you know, downshift, ram it, and then slam the brakes, and I park in front of the garage, right? If somebody was parked in my spot, I would know when I hit the car. It's that automatic. The sprite manager, the sprite will just keep pushing stuff out automatically. It doesn't even think, like boom, 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 sequentially, right? So if I come in here and I have this little guy here, and it's going to go, you know what? I have a pointer to you. I have a pointer to another image. And this image is, oops, as a squid. I'll sit there and say, you know what? I'm going to do something evil. I'm going to break that connection, and I'm going to have it now point to this guy. Now, meanwhile, somebody still says draw, and you're like, oh, okay, well, it points to this guy, and suddenly this guy is drawn. Does the sprite know it happened? No, it draws whatever it points to. It doesn't even know what it points to, right? So now imagine, 1, 2, 3, 4, 5, and we're going to switch images. 1, 2, 3, 4, 5, switch images. 1, 2, 3, 4, 5, switch images, right? So this guy is going to switch from this one to this one every 5 seconds. And it has a pointer to this, has a pointer to the 2 images, and it keeps switching. Now suddenly this thing's flipping back and forth between the orange one and the green one, the orange one and the green one, orange one and green one, and now you're animating. So let's talk about how it works. All right, so here's the animator. So first I'm like going, well, let's create an animated sprite. So dunk, 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 dunk. So I'm just switching through a couple of these. So white, blue, green, pink, white, blue, green, pink. So I'm switching through 4. Same one sprite. I only have one sprite on the screen. And what I'm doing is I create one sprite. Where is this? So I'm taking the Pac-Man and I'm saying, okay, it's a blue ghost. And what I'm going to do is I'm going to take that one sprite and I'm going to say, you know what? Sprite animation, attach these different images, white, pink, green, blue, right? Then we add a timer event and it's basically going to swap it for me. So here's my timer event. And so use the P animation. And what's going to do here is you have, so probably the best way to do this, do I have a diagram of this? Yeah. All right, so we have the animation. The animation, sprite animation, has a linked list of images, but it's image node and it points to the image, right? But it's going to also point to a sprite. A sprite is also not, now you have to play this game here. The sprite has a sprite base. Oops. Oh, sprite, that's right. Sprite has fields image. It points to this. I hate that you can't duplicate easily classes. All right, so this sprite points to an image. This one points to an image. And so what I'm going to do is swap between these two. So I'm going to swap. So this sprite, I'm going to swap its image with something off of my link list. Right. So let's take a look at this. So I create a sprite animation and I initialize it. So there's my sprite animation. I sit there and say, find the name sprite. So I'm using by name. All right. Add a link list manager. And then, so I basically got everything ready. So there's link list manager. So then I'm going to say attach this image. attach this image, attach this image. So what I'm going to do is attach it, add to the front of the linked list manager, and have an iterator. Right. When I call execute, it's going to sit there and say, give my iterator is next equal to null. No, go back to the first and loop through this. And when it will, get the next one on the list, then swap the image and add a timer back. And it's going to be off of a certain delta time. So, so let's do here 0.5. And then let's just go with the bird. Right. And you can imagine when we're dealing with Space Invaders, we can have, I'll collect this. Thought I had we can go this alien, and we go boom, boom. So it's like it's marching, dunk, 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 dunk. So, close, little spread, close, spread, dunk, 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 dunk. And so when they march, they kind of jumping jack, close, out, close, out. And this could be two images, and we can have it toggle by a certain time, like just swapping what it points to. So, so at this point here, we have the mechanism in the timer, but the problem here is, why do we need to have this whole overhead of an animation, sprite animation? This is really just a glorified timer. So we shouldn't even have this as a timer. So the next pass is to basically rework it. To an animation command. And so this is a little bit cleaner, in my opinion. All right, so here. Animation command. So here's my animation command, which is the same thing here, but I associate the sprite name. So basically, I think I just moved it to over here. The more I think about it, I don't think there's much different. And it points to a sprite, it points to the manager and the iterator. And there you go. All right. So animation command. Did I diagram it? Yeah. So here's the animation command. So animation command basically drives from the command. The command pattern, as we know, is just as execute. It points to one sprite. So this is the one sprite it always points to. Always points to that sprite. I'll put it up here, right? And this sprite has image as a field. Right. So this points to sprite points to an image. So just ignore all this for a moment. Now we have hanging off of this an iterator. The iterator was we have a linked list manager. Linked list manager has a linked list to an S-link. S-link has an image node. The image node holds a pointer to an image. It's a lot of overhead to get this in here. So this adds to an image. Now I have a linked list of images. And and I have a pointer to a sprite. And so on execute, I basically said, okay, give me the current iterator. And then I basically said, am I about to walk off the earth? So I do next, am I off the earth, edge of the linked list? Yes, go back to the first. So I go back to the first, swap the image, then add myself back to the timer. So now I can animate through these linked lists. And if we just change the pictures, we get the guy marching. So questions? So what we just combined is a priority queue. So again, why do we have the priority queue? Is that imagine we have all these timer events. Right. And if they all are inserted by time, so this is time, 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 time. This is the smallest. And this is the largest. We can now with the timer, saying, okay, my current time is 100. And let's say this is 101, this is 98 and 97. Well, then we go, okay, go process these. We go, okay, execute, remove, oh, greater than, stop. Because we know everybody else is greater than that, so we don't have to check a million of these. We just stop there. So a priority queue is inserted into order, and it stops us from what's the word I'm looking for? Stops us from processing more nodes than we need. Right? Each of these timer events. So this is a timer event. Oops. Event holds a pointer to a command, and then the command can be anything. And this is going to have a trigger time and delta if it's repeated. So it's the trigger time is a delta. So whenever you add something, so we're adding the timer event, you say, okay, add it, and I want it to be 5 seconds from now. So 5 seconds from now, it'll be, if our current time is 100, this new guy would be added at 105. You don't do absolute, you do that. Now, when you buy it, it's delta, and then when it gets added to the list, it becomes absolute. So I tell you to add an event. I say add it 10 seconds. In 10 seconds, I want something special to happen. If our current time is 100, I go 100 plus 10. That's the time I added into the list. So our time is always absolute. Our add is always delta from current time.
What are your thoughts about like doing like a priority queue manager, kind of like we did with the D-Link manager?
This is it. This timer here is a manager.
Yeah, this is the insert sorted order. That's
I see what
method.
you're saying. You're saying the D-Link manager making an inserted one. Yeah, you
Well,
can do that. Or I would just add a method to D-Link manager.
That's what I mean. Like insert just, insert sorted order, right?
Yeah, insert sorted order, and you give it a key.
oh, okay.
You
Yeah.
could even do a condition to sort on as well, if you really want.
Yeah, if you want to be very fancy.
Yeah.
But the thing here is, one of the things I've learned, and this is a hard lesson learned, don't speculate too far in the future. Write your code just enough to get what it's working,
Yep, exactly.
and because then you're going to have to refactor it anyway later. So if you spend all this time like, oh, and then we'll do this, and I can do this. First of all, you're almost always guessing wrong. And if you keep the code smaller and minimal, it's easier to refactor. So I would sit there and say, you know what, I would add insert, you know, by key, you know, and here it is. And, you know, and just add that method. But yes, you're thinking right. Okay, I didn't quite understand that. But this timer overall is a priority queue. So it feels like a normal manager, except that when you add, it adds it in an inserted order by its value.
Gotcha. Yeah, I just didn't like the name like timer. Just because it seemed more like it's very specific.
Well, the timer is just the drive class, right? It's just because everything's going to be associated to this time location, right? So, you know, this right here is like every frame you have your timer update. I don't care what you call it, but you're going to have to update something once a frame, and it's going to hold all your timed events in a queue. So I call it timer event manager. Whatever you want to call it, you can. And so the timer event manager, you know, it's the whole timer event base, blah, 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 blah. But here, I think is what you guys were talking about is add to front, at the end, you know, insert by a certain key. Then you can sit there and say, okay, node can give you a key. So you know, have a contract for a key, you know, and then it gives you the key. Yeah, pretty easy to modify. Okay, other questions? All right, so now we're starting to cook with gas. Okay, well, here's one of the problems right now is that what if I want to draw 5 objects on the screen? And the only difference is their position. How would I draw that? Well, one of the problems is I want to draw 5 on the screen, so let's do that. So let's say we have a sprite, and the sprite has, you know, all these variables, rotation, you know, angle, scale X, scale Y, you know, image, you know, dot, 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 all these different things. And it has X and Y, right? You know, as the first 2 fields. And then you're like going, okay, this draws one guy on the screen. You know, I want another guy on the screen here. And everything's the same. So all of this stuff is exactly the same. Instead of this being 5, 5, this is going to be 10, 5. Right? And all this is the same. The angle, SX, SY, image pointer, right? But then I want another one, the same thing. But now it's 15, 5, and all this data is the same. Seems like there's a lot of extra data there that's the same, it's not changing. And you know, just to draw another alien on the screen. So this is where another pattern comes into play. It's called a proxy pattern. And of course, I did put it there. All right, let me see. I'll grab my old proxy pattern. All right, proxy. Where are you, proxy? I'll find it. There's proxy. All right. So proxy pattern, it's real simple. You have a real subject and a proxy subject, right? Let me show you another option here. OO design proxy. And so you have a real subject that has a lot of fields, and you have a proxy subject that has just 1 or 2 fields that are varying, right? So the idea is that you want to reuse this stuff. So let's go look at reference design. Proxy. So a proxy pattern basically says you only have to store that real data once, but you can have a smaller proxy object in its place. So here I just did with cars. So your car can drive, right? And you have a real fiat, and this has just lots of fields, right? You know, and then it can drive. It can, basically can drive, right? So we have a proxy, and so I want many cars, but I want them at different locations. Same car, I want a whole fleet of, blue Fiat 500s, but I want 5 cars all in different positions. So I just have the different position, and I have a pointer to the big real one. So proxy points to a real one, and so when I want to drive it, I need to push my XY to my real one and then call drive. So what I'm going to do is copy this field and copy it over to that. Copy this, copy over this. Now call your drive. So whenever I do a function, the first thing I do is I overwrite the 2 or 3 or 1 field that's changing. Then I call and delegate and have you do the work, the real one do the work. So this is, so here it is, here's a real fiat that has a lot of fields. And I just create 3 different fiats, car A, B, and C, and I call drive. So when we call this, it's really lightweight. And so we call it, it's like boom, to set your XY, and then the pointer to the real guy. Cool. And now when I call drive, the first thing I'm gonna do is I gotta copy my XY over. So I go copy it over. And then I delegate and say, you call drive and you do drive. And that's the proxy pattern. Really, really simple, really efficient, and helps us a lot. So let's see how we can use this in the game. So here's proxy. Come on, didn't want to change it there. Okay. All right, so I have a diagram. Proxy. All right, so here's my proxy. So proxy manager manages the proxy manager has a linked list of sprites bases. The so basically has a linked list of sprite bases. So in this case here, the the proxy points to the full sprite. It has this XY. It's going to push the data XY over, then it's going to call render, and it pushes and calls that render, or update calls that update. So now let's see this in action.
I have like a concern. Since sprite update to update the Azul sprite, that supposedly takes time, doesn't it? So every
yes.
time you move the sprite to draw it.
No, but you're only drawing it once. And you're only drawing. You're only calling update once.
Per proxy or per sprite.
Per sprite, right? And you have to do that anyway.
But you have, I guess you're right there.
And so what's happening is this update doesn't call it. This update says push my real values over, then delegate it and call your update. So it's all I did is add a push of XY and then I called update. So it's approximately the same cost.
Okay, I think I get it.
Yeah, so it's kind of like this. Let's pretend this update costs 100 cycles, right? This guy isn't doing the 100 cycles. It's saying push XY, boom, boom, then saying, hey, knock, knock, you call update. And it goes, okay, I'll do the 100 cycles. So this just delegates it over and it says, not my work, it's your work, you do it.
So it's like this, it's really just the same thing, but
It's
just,
just a push.
yeah.
It's just a wrapper to push it. But the
Mhm.
difference is I don't have to carry my Azul sprite. I don't have to carry my image pointer. I don't have to carry my color. I don't have to carry any of this stuff. I just have to worry about the two fields that are different. So let's talk about bytes here. 4, 4, 4, 4, 4, 4, right? 4, 4, 4, right? Just literal. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's call it 10, 40 bytes. Then a real sprite object is, 80 bytes. A real image points to a rectangle, which then points to this. So let's call another, 20 bytes there, another, 16 bytes there, right? So all together, we'll just call this whole mess sprite with all of its appendages, right, is 150 bytes, right? Now let's look at what's the proxy. 1, 2, pointer, 12 bytes. So every 12 bytes, I can reuse this 150 byte monster. So if I add 10 proxies, I added 120 bytes. Or if I do 10 full-size proxies, I would need 1,500 bytes. Are you seeing just the size difference? And remember, smaller size, more in cache. Smaller size, more in cache. And that's going to give us our speed increase, right? Also, it's going to give us our reusability. But there's a secondary side effect here that I'll explain in a second. All right, so let's look at the game. The game here, I create one full size sprite. It's called Yellowbird. So there's my full size sprite. Then I'm going to basically go, let's go create 10 of these. Dunk. And it's changed to X, right? Attach, attach, attach. And these are the proxies, right? So now, boom, there's the 10. They're not 10 deep copies. They're not 10 heavy proxies. I mean, heavy sprites. It's 10 little baby sprites, all point to one Yellowbird, right? But now I'm like going, no, 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 not Yellowbird. I want it to be a green bird. Now all 10 of those now suddenly magically switch to green.
How is it able to paint that one instance of the sprite multiple times?
Because it's calling each of the proxies. So
So
like the very first, like before all the proxies like execute for that frame, does the sprite reset to the original spot?
no, I'm sorry. So we never draw the real, we only draw the proxies. So here, let's go to this. We have a proxy, right? Right, the proxy points to a real sprite. We'll do a Yellowbird, right? Right, and so this connects to image. This connects to Azul. Right. Okay. And this has tons of fields, SX, SY, angle, name. Okay. This proxy only has X, Y, and a pointer to it. Okay. You can have a name, we can go as elaborate or as small as we want. This guy here is the only thing added to the Sprite Batch Manager. This guy is never added to the Sprite Batch Manager. So this is
If you don't have that individual proxy names there, would it cause all of the sprites
Yeah,
to be
I don't
nice
even-
in the animation, for example?
I don't need a name at all. The
But
name, they're-
if you don't, but if you don't have it, would it cause all of the animation to be the same then? Because
okay, so
you're referring to the name, right? When you're changing
No,
the sprite
yeah.
or not?
no, the name is just there, so I don't have to have the pointer. I let somebody else search for the pointer. So which name are you talking about? We have two names here.
The proxy. If
Proxy?
you don't, yeah, if
You don't need a name.
yeah, but then wouldn't all of the proxies be have the sprite swapped at the same time?
Well, they're all going to anyway because it's all pointing to yellow. So you got this, right? So you have many sprite proxies, right?
So yeah, that's what I meant.
Wait, just wait a minute. Wait a second.
Okay.
And so these all point to one yellow bird, right? Right. So this is, proxy A, B, C, D, and E. And then this guy points to yellow bird image, right? Now, if I go in here and go, you know what? No, you point to a red bird. Then all these now are red birds. Is that what you mean?
Yes. So if I wanted to create not
Well-
have all of this synchronized, I would have to do
Right,
the
but
name
that's actually to our advantage.
yeah for
Because
the Space Invaders, right?
right, for Space Invaders, because we want the guy to look like this. Dunk.
So there's only one instance of the sprite, but many instances of the sprite proxy.
Correct. Absolutely correct.
Thanks.
So then if we change that one instance, everybody in by nature of the connection changed too. So now all these proxies, A, B, C, D, all point to the one guy. Right? Then when we swap this thing here to, we break it and we swap it to red, now all these guys get redrawn. And if you kind of go back and forth, dunk, 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 they're marching.
I'm still a little bit confused about how like this is even possible, because like we should only be able to have one instance of each sprite from
No, you have one real sprite, you have 10 proxies that point to the one real.
I think the confusion is like so when you call update, like right now with the sprite stuff that we have from like say Sprint 2, you
Mhm.
call update, it updates all of the Azul sprite stuff, it updates all of that, and then later on you call render and the whole like sprite, Azul sprite, everything moves.
Right.
So I think where it's confusing is when you say you delegate the draw or the drive to the like the real car or the real sprite, how does that not just move the sprite along the screen instead of just like you're displaying 10 of
Exactly.
them?
Okay, so let's chase one guy through, right? So here's A, right? And so percent his position is 100, right?
I think part of it is that when you draw, you're putting it on the screen
That's
and
all
you
you're doing.
don't clear it until you draw another one. So you draw, move, draw. It's like a stamp. You're stamping.
Yeah,
aliens on the
exactly.
screen.
It's a big stamp. You go stamp, 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 multiple locations.
No, I'm concerned with like because Azul, it looks like it does render and update in different steps or in
Yes.
different.
Mhm.
So you'd have to.
No. You remember the update. You have to update the Azul, and you have to update the render, right? But you can have on your local object, you can change that value XYZ all day.
But you're just saying that you're gonna have to change it anyway if you want multiple objects. It just saves space to have proxies instead.
So you'd
Right,
have
it's
to
a
update it before
drawing.
you draw it.
Right. So here's B, right? And here's X equals 200. And here's C, X equals 300, right? So you still
So-
have the three boxes, right? But then when you say draw, right? You're going to sit there and say draw, and it goes, okay, draw proxy A. So A, proxy.
So you'd have to call, update, and then immediately draw before you go to
Exactly.
the next one. And
You're
so
gonna
you have to do it in the same
you-
step.
Yeah, you go
Basically.
push, push the X, Y. Then you're going to sit there and say update,
Okay. So
and you say draw.
we're updating in the render step then, or in the render, whatever.
Remember, this update is we're overloading the word update. There's multiple updates. One is this variable XY. You can change this all day. That's updating, right? But when you push it to the hardware, you have one time to push it. That's the update to the Azul.
That's what I mean. So you have to push the hardware before you render,
Right.
and you have to. And since you're doing it all at the same time, you'd basically be doing it all in the same.
Right. So let's look at the batch. So here's the batch.
Okay.
And it goes into the draw. It goes, okay, I'm going through the first strike batch, call draw. Oh, cool. All right, now I'm going to sit there and call this. I'm going through the node, right? And the node is going to point to a sprite base. Sprite base is going to say render, right? All right, so far, same, right? Here's where it's different. The proxy diagram has sprite base, and then it says, okay, I still have, this is a proxy. So this in here is I should probably hide so you don't see it, right? So now what we have is this. So when we call render here, it goes, okay, render it. It goes, okay, render. It goes, okay, render. Push the XY to the real guy, call update, and call render.
Okay, this clicked for me when they said you're moving the instance of the sprite and then creating a stamp and then
Yeah, we're stamping it. That's the big win. But because we're sharing one guy, suddenly we get some advantages of that. So when we change that one guy's image, everybody's images change. So we can animate 11 guys with one timer animation.
Okay, I got it.
So it's really reusing and sharing at the same time. So so here's all those proxies, and those proxies all point to the same real guy. So let's put the real one here. So they all point to the same real. And so when it moves through there, it goes, okay, copy this data and then push it over, then draw it. Then copy this data, push it over, then draw it. Then copy this data over, update it, and then draw it. So, if we want, maybe we should change this word because this update's confusing people. So we should do maybe is instead of just calling this update, we should call this transfer data.
Could you show the
Maybe
render?
right
Yeah, right. Or
or
yeah,
flush.
flush. Yeah, it's really like a
Or-
flush. Flush is probably the better word, I would say. Okay, what did you want, Robin?
Could you show the render real quick? For the actual real sprite class.
This is right here.
Yeah, no, I mean like the actual code for that. What I don't get is like, so where I'm still confused is like that update looks the same as, what you do with the regular sprite. And that render looks the same as what you do with the regular sprite, but like,
No,
when I
You're
move
delegating
this-
it. You're delegating it.
No, I know, but like in the existing stuff, when you call your update and render, like you're not stamping it on the screen repeatedly. That's the part I'm confused about when you're moving
Because-
something across the screen. I
It's
don't
because-
get how it pushes down to the Azul sprite.
Okay, so before we go too far down this rabbit hole, and until I know where you guys are going, the next incremental step is game object. So what we need to do is separate is this moves a physical game. Like this is the object that we collide with, that has points, that has a sound effect, it has all this stuff. That's called a game object, right? The game object associates to a sprite, and that's what we draw. So what we really do is we update the game object and then we draw the sprite. Right now, to this point here, the confusion is in this is in sprint 2 and sprint 3, we kind of use the word sprite and moving something on the screen interchangeably. And what we're really going to do is separate duties and responsibilities, right? So we have the idea of this is that here's your game object. Right? And it has X and Y. And then associated to this is the sprite. And so now you go this and you change this all day, right? And then when you're ready for rendering, it goes, okay, this stuff gets moved over to the sprite, which then gets moved over to the Azul sprite. And so by having it this way, we have a very hard line here, this hard line of responsibilities. So think about this. All we work with and interact with in the game is the game objects. Magic happens and it draws it to the screen, right? So the magic happens, that's another layer, and that just transfers it over. Right? And so what we would have in reality is that this would be a proxy sprite. And the proxy sprite would then delegate to a real sprite, which would then delegate to a Azul sprite. So the game object this is where you move the object, you collide with it, you play sound effects, you have points, you do anything like that. That's a game object. And then attached to a game object are sprites, and they can be proxies or reals. And then if in this case we have a proxy, the XY goes from the game object, it goes to the sprite, a proxy, and the proxy then pushes the XY to the real sprite. The real sprite then calls Azul, do your magic. Does that help at all? Differencing abilities here. Responsibilities. Remember, we're just prototyping. We're just trying to get our infrastructure in there. So let's continue on for a second. This maybe will clarify a little bit. All right, so that was proxy, and basically the whole catch is it draws multiple items. So let's look at the game object. So the game object is, instead of me drawing and managing sprites to move around in the game, I have a game object that move around in the game, right? And you're like on the same, but no, actually I can do more with a game object. So my game object here just has X, Y, and a pointer to the proxy and a name. That's it. Because this is what I'm going to really interact with. I'm not going to rotate. I'm not going to use angle. I'm not going to do scale X, scale Y. This is what I'm going to use, most of the time. Just X, Y, right? That's it. And the names, they're just for fun. So here's my birds. And what I do with my birds is I drive it from game object. So green bird drives from game object. Red bird drives from game object. So I have a game object manager because my game objects are going to have different sizes, different shapes. It uses a node pattern. So the node points to a game object. The game object then has a white bird, red bird, a yellow bird, a green bird, right? And then we'll talk about this a little bit in a second. This is a null object that does nothing. Right? The contract on this, right? So this does nothing. So this is their back to diagram. The methods. The methods are update, just update. That's the only method it really is in print. Right? So let's get rid of those. All right. So now this is the game object now. All right. So okay. So I have, let's go to the game. I'm here at the game. And basically what I'm going to do is say create a green bird at 150. Attach it to the game object manager. So I created a game object manager now. So here is a game object manager, that whole mess. And it's going to hold game object nodes because the game objects will be different sizes and different shapes. So I have to do the aggregation approach. Okay. So I attach it, then I create a red bird, attach it, and yellow bird, attach it, yellow, just attach it, right? Now, on this attachment, first thing here is when you go yellow bird, it goes, hey, I have a sprite name, so I'm just going to turn around and kick it upstairs to my base class. And my base class goes, okay, sprite name, got it. Now go to my sprite proxy manager, find it, return it, and associate it. Right now in my game, I'm going to move the object. Move the object, and I'm doing it really moronically, but I'm saying find the thing called white bird, return the pointer, move the parameter, and do this. When I'm all done, I call update every game object. So I'm working on my local copies of XYZ, XYZ, XYZ. And then I call update local object. So here it iterates through. It calls the game object update. And this is just going to update the proxy sprites that are associated with it. Nothing more. So basically I play in my game object playground when I call, and this is all going to be managed by a big guy here called a game object node manager, right? So I'm going to play, keep changing these and change the values. When I sit there, say no manager update, it goes, okay, whatever this value is, now it's there. And I stop. I just kick it over one fence and stop. Now, this area here is all responsible by the sprite batch. So sprite batch manager is now responsible for this whole thing, and its job is to draw a sprite on the screen. The game object manager's job is to move it around, collide, do points, trigger off events for like sound effects. Once I kick it over, now it becomes the sprite batch managers to render something pretty on the screen. So at this point here, I call sprite batch draw now draws all the proxies. So here's my birds. Each bird's moving and they're moving at different rates. And then when they hit the top of the screen, they just snap down to the bottom, right? And I'm doing this very moronically. I'm doing all the code here. I'm doing all the code here, right? So then if you look at my construction of this, like create a green bird, I have to know it's called green bird. Here's the name. Here's this position, right? So then I like go create a red bird. Now, if we look at this right here, this screams, create a factory will make life a lot cleaner and smaller. Create a factory for me. And it's okay. And in the factory, I just pass in the name of the bird and the size, and that's it. It just creates it and it attaches it to the game manager. So the next step is now I'm going to I created this game object, but yet in my previous drop, get rid of some of these. Okay. So in the previous thing, in this version here, I would sit there and move it directly. Go find it, then move it directly. Go find it, move it directly. Then I say update, which transfers all my game object XYZs to my proxies. Now, in the new drop, I'm like, when I got game objects, why not use it? So I moved all the movement. Oh, I didn't do that yet. What's the new one? Let's move it. Oh, so I have the same thing here, right? This is my here. Here's my update. So I moved all the movement internally to the game object. So now my game object, I just say update. And what it's going to do is call in each game object. So the game object has a contract. Right here, update. So I made it virtual because I want a default behavior. My default behavior is to transfer it over. And then in my birds, so here's a yellow bird, I have the choice. I can override and replace the transfer and say, okay, here's my new movement. Then I can call the base to do its job. So basically I moved everything encapsulated into the updates of the game objects. So now my game objects, I define how I want it to behave. And then instead of me calling update every single frame, so before I would move it directly and call update. Now my game just says update, like, okay, update. And then what we do is iterate through everything on that linked list and call update. So then in this case here, I'm going to show you, get to this point here. Now I'm going to go into it. Now I'm calling updates. It goes into it. It goes into the games. This is yellow bird update. It goes, okay, move its X, Y, Z and call update. And then go to the next guy. Move its X, Y, Z, call update, transfer it over to the proxy. Go to the next one. And I keep doing that. And so now what this saves me is I'm already in there. So I know my pointer, I know this. So instead of me doing a find, I just by the fact that it's class object, I'm inside of it. So I have access to this pointer. So I don't have to do that search. Then I can put any of this complicated code buried into the game object itself. So game object, I put this buried code into it. And so now it's a standalone movable item. And then when it's done updating, it just transfers the data over to the proxy. So when I look at this, I'm like, okay, cool, I'm moving objects. It's using a proxy. The proxy is being drawn here because the proxies are unique instances. The proxies all point to a shared real sprite, right? So now my new problem is this is just ugly. So now I add a factory. So now I'm adding a factory, and I did that. That will demo on purpose that way. All right, so here's my factory. Create a bird factory, and it just takes in. There's my bird factory, and my bird factory has the data sprite batch. So I set and pass in my sprite batch. So find my sprite batch name, find it, register it, and keep a local copy of the pointer. Now, when I sit there and say create, I can just go create green bird, red bird, white bird, and then give it its position in X and position in Y. And here I can create, here's 4, and then create 7 of these. So I just create 28 very quickly. Right? The reason why they're all moving in unison is because they're all pointing to the same object because I have the proxies. So this really shows off the proxies, but in reality, we wouldn't have the proxies. So we just have one. So there's all the objects moving up. So now, instead of this big mess I had before, here's my whole factory. Here's my crate. And the bird factory is going to return crate. I'm sorry, the crate's going to create a game object. So creates a game object so it knows which ones to call. It returns the pointer to the game object. That pointer gets added to the manager and also added to the sprite batch. So here, just right, so there's the 4 guys kind of doing their thing. They're all in different spaces, and now when I create this, they're all sharing the same green, same object, position XY. If I want these guys to have different, if I want them to have different XY, so like here, I can make multiple green ones. So now I have unique game objects for each one of these, but they all share a common green sprite, real sprite. So what I have now is this. Let's see if I have a diagram. Game object, base, green bird. Game object points to a proxy. The proxy points to a real sprite. The real sprite then has all its data, and one of the fields is the image, and then another field would be the real, no, there you go. There, the real Zool. So this is kind of where we're at, where a game object node manages game objects. The game object has a aggregation pointer to a game object. Game object then, here we have the bird base and the birds underneath it. So here's the movement and the update to the birds. Movement, and then the update goes up a level to here, and it has a default update, which just says copy the data to the proxy. And then this XY gets copied to here. Now this guy here is part of a sprite batch. So we have a sprite batch manager. Sprite batch manager. Boom. And then the sprite batch manager points to eventually manages sprite batches. Boom. And then the sprite batch points to sprite node. And the sprite node points to sprite node manager. Oops. And then this eventually points to sprite node. And then this points to a sprite base. Well, easy as pie. Hang on. And so now we have this. We have this thing kind of on two lists at the same time. We have an object manager managing node objects, which has the game object. The game object is a green bird. The game object also points to a proxy. The proxy points to the real sprite. And the real sprite has the green bird image. Meanwhile, the sprite batch manager has managed many sprite batches. Sprite batches have internally a sprite node manager. A sprite node manager manages many sprite nodes. Sprite nodes have a sprite base, and sprite base points to, this is a P, not a PO, points to the proxy, and the proxy then will render. This should be hidden there.
I have a question, might be a bit basic, but I don't really understand why you're using double linked lists instead of single ones, and just how do you decide when to use each one?
So when your volume gets large, right? So you have a couple hundred of these. Now you're going to remove the last node off your list because it collided, right? How do you to remove a node in a single link list? You have to, the worst scenario is removing the last one or the second to last one. And so you have to iterate through the whole list to find the guy before you, the previous, to correct its pointer. So
Okay.
a double link list gives you order one removal.
Okay.
That's it. There's no fancier reason than that.
Yeah.
If you're dealing with something very small amount, and this is a subjective thing. You have to almost like test it empirically to figure out what makes sense. But a small amount would be like, I would say 5 or under or 10 or under. It's not worth the overhead, right? So like my animation controller has a linked list of images they can swap between. Those are all S links because they're not that deep. I'm not expecting to have more than 3 or 4 of those, at a time. So to remove any node, worse off I'm walking through 3 nodes to figure out who's the previous, right? So that's not that costly. Um,
Thank you.
all right, so last part is the composite. So now we want to have a lot of aliens, and this is the grid. So I'm starting to call this collection of aliens. You have, so many there, and then you have, so many bottoms, right? So this whole collection, and then, dot, 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 and there'd be 11 across, 5 of these. I'm calling it the grid. So this is a grid. So now we need to manage, control, and move the grid as a unit, right? So now we have a problem is collection. How do we deal with the collection? So a pattern for this is called composite pattern. And this is a little bit confusing. And everybody's reference is actually very inefficient. And I'll explain why in a second. So here's the composite pattern. Of course, I don't have it there. Jesus.
There was a composite PowerPoint there.
Yeah, I thought I did. Oh, was it there?
There was, yeah.
Okay, I'm just scanning right off.
D10.
Yeah, yes, thank you. All right, so composite pattern. So the composite pattern is just a way to compose a groupings, right? So it's a groupings of groupings, right? And so here is, there you go. So basically you have a component, and then you have a single leaf, or you have a composition of components. So basically you can have, let's say, 1 leaf or 5 leaves together as a node, and you can have a tree of nodes. And this is a very hard one to kind of like visualize and, at first, but you basically have, it's basically you're making a tree, so you sit there and say any one individual item is considered a leaf. A collection of items is called a composite. And then you can have obviously a leaf. Here's multiple leaves, so there's a collection, and that can be a leaf on multiple, so this is leaf, this is a leaf, this is a leaf, this is a collection, but they all behave as a leaf to this collection. And then this one, it has a collection of collections, right? So it's basically just a way to programmatically create a tree. I'm not, I have a different technique that I use in my later architecture courses that I created from scratch. This is kind of the standard OO approach, right? So you can add, remove, and you can get the child. And basically the composite is a collection of components, right? So this one, we totally need a reference design to show you this. So a composite holds multiple leaves, multiple components. A leaf has no children. It's kind of the going problem here. There's a composite pattern, right? And it's, there's not much there. A leaf has no children. A composite can have a collection of components, right? So let me show you how this works. In the program, I sit there and say, okay, create a composite. And now what I'm doing with all my things here, I want to give it data, so I just gave it a name. So composite has a name, a leaf has a name. This way we can see it kind of in action. So I said, create a root, and it's called root. All right, create a new leaf A and a leaf B. And I said, take my root, add A, take my root, add B. So now at this point right here, Here, that's probably the way to do it. All right, I just got to composite and imprint it, right? So here's my composite. And when I create and add a root leaf, I added a leaf. It's owned by the composite, so I indented it on the print. Now I'm going to create a second leaf and add it. And there it is. So root, leaf A, leaf B. Now I'm going to create another composite. And what I'm going to do is call it composite X. I'm going to add leaf A and leaf B to it. And I'll add it to the composite. Right. Then I'm going to add this composite to the root. So I have leaf A, leaf B, their parent is root. I have composite, and the composite has two children, XA and XB. Then I can add another leaf here to the root. And so this pattern here, let me show you what it means in diagram speak. Is this root, right? And then we have a child A and a child B. We have another composite, which is X, and it has a child XA and XB. And then off of this is at the same level as C. So there's your levels, right? So whatever diagram you want, let's say you want A, let's say you want this pattern right here. You got to kind of create this. All you can do is attach, right? So in this case here, if we want B and C and D and E, F, G, H, I, and J, you get the way you go about this is you sit there and say, all right, I will create this. I will create this. I will say B attaches to A. Then I'll say E is attached to A, F's attached to A, then G attaches to F. So let me try to do that diagram really quickly. All right. So this would be A, right? And then the B will be a composite. B, B, and then F is a composite. G is a composite. G. All right. All right. So what do I have now? Okay. G has H, I, J. Right. Oops. Okay, and then these are going to be combined under G. So I'll do PG, add H. G. Okay, so I got all this done. Now I'm going to add G to F. Right. So now I got all of that done. I go B and then add C and D. Okay, now I'm going to add B to A, E, and then F. So PA, add B, P, P.
What is the difference between, so like this uses a tree, right?
Mhm.
Like, why do that instead of just have another collection, some of the batch sort of thing, where you can just kind of throw them all into a list and they're all moving together, which is the point. It's like, what does this being a tree
Oh no, this
buy us, or
tree-
is that just the pattern?
this is the pattern first thing,
Okay,
and I forgot I didn't create the nodes here. G, C and D.
So composite is kind of like you have like a specific arrangement. Is that kind of like what
Yeah,
this
this is basically a tree.
Like I know you know, but it's like a specific arrangement of like nodes in the tree, and that's the composite, or something else.
The composite just has multiple children, one or multiple children.
Oh,
A leaf has no children. That's the only definition.
oh, okay.
Yeah, this is one of the things where it's easier to demo. All right, so PB, almost there. Leaf. Okay, there's P. And then F. Okay, so P, E, P, add P, F. And print PA. Cool. All right, so I think that sounds right. Let's see what mistakes I made. All right, so we have A, its first child is composite B. B has child C and D. Then A's next child is E. Then A's next child is F. F has a child G, and G has a child H, I, J. There you go. So that's how you use it. And why are we doing this? This is going to be the basis for our collision system. So when we have our aliens, like I'm just going to do it. Here's the aliens. Right. Okay, so we would have columns. Then grid. So we have grid, right, followed by column 0, column 1, column 2, column 3. And then inside of each column, we'd have right. So I'm with all the appropriate connections. There's our tree. So what happens is the missile comes by and it's moving up, right? If it misses the column, the grid, it goes boom. I do one check red missile. Let me just give this a different color. Missile, right? I go missile versus black. One check. I didn't check all, in this case here, 4 times 5, all 20 boxes. I checked one, right? But now if my missile intersects, right? Now I go, okay, there's one check, so missile versus grid. Now I check each column. I go, okay, it missed this one, missed this one, this one, this one, it missed. So it's still no collision, stop. So I do 4 checks. Then when my missile actually starts hitting a column, I go miss, miss, miss. Now I just go down C1. Now I check these. So it's basically a tree of collisions to reduce our complexity. So I check here and then I go through this and like, oh, here it collides. Okay, now I'm going here and now it collided with this blue one. Instead of me doing 20 individual checks, in this case here, I did 1, 2, 3, 4, 5, 6, 7. 7 is my worst scenario, or 7 to 10. And then as you start to delete guys, okay, so then this deleted, your grid shrinks. And then you delete this many aliens, your grid shrinks. And then appropriately, your grid starts shrinking here, right? And then it's like going, oh, I killed this column. Now the grid shrinks. And so now it becomes adaptive collision boxes with hierarchy. So that's why we want it. Now, what we have also is this. Imagine you have 3, 3, 3, column, column, column. Right? And so in this case here is 1, 2, 3. Right? And so these are, you have the columns, then you have the grid, right? But now let's say you want to do movement, motion, right? All you do is you say, add to, to the X direction, I don't know what we're going to say, add X to, you do it this node, and then it propagates to its children, just one level. Then the children propagate to all of its children. And now suddenly, boom, the whole grid moves to over by 2 pixels. Right? So the goal is not to sit there and say, I can put an iterator and touch every single node, right? And move it by 2. Or I can sit there and say, all I have to do is tell the highest node to move by 2 and let the highest node propagate it to the next level. Then that one propagates to the next level, and that one propagates to the next level. So I'm starting to get some advantages here with this relationship. So here is the composite pattern, and we'll go over this more next week. to kind of, get this composite pattern going. And that's like the last thing to go. So did you guys see this commercial? I was a number of years ago. It has hamsters commercial. Row. The gecko commercial. I don't know if you've seen this one.
My electric bill was breaking the bank.
Yes.
So to save some money, I trained this team of guinea pigs to run
Oh, guinea pigs.
They generate electricity, which lets me serve the bill all day. 6 months to train each one, 8 months to get the little chubby with the yellow row. That's strange.
Can't really hear it too well.
Yeah, it's poor. I'll try to dig up a better copy. But anyway, the whole idea is, if you think about it, one of those old pirate movies where there's the guys in the dungeon in the bottom of the boat and they're rowing together, and there's the drum master, dong, 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 and it's row, row, well, what's going to happen with your aliens is that they're all going to march on the drum beat, move over a step, drum beat, move over a step, drum beat, move over a step. So you want these things all synchronized and locked. The drum beat you'll control by the timer. And then because they're in the composite relationship, you'll pass the new position over to the root node, and then that will propagate it down through all the other nodes. And so we're getting close to where we're starting to, kind of get more complex behavior here moving. So I give you this thing to start off with to look at. When you look at the information for composite pattern, you'll see in the composite pattern a lot of times, the composite pattern a lot of times has do factory composite. They do one thing, and then I want to leave because I know I'm going long. They have right here that the composite pattern has the children, right? And the problem with what they're doing is they make the children an array. A collection, or is it composite pattern? Yeah, here it is. It's a collection. And we're not using generics, and sometimes you'll see people actually use arrays, dynamic cast arrays. So both of those things are kind of against the rules for this class. And the reason for this is we're trying to do a real-time class. And if you know how dynamic collections work, if you have an array and you sit there and add number 5, you go, I want to add more to it. It's like, oh shit, it'll turn around and create the space for 2. Copy 5 over, mark 5 for death. Now you can add the number 6. Oh, I'm going to add another one. It doesn't have the space, then it grows it out. Copies 5 and 6 over, marks this for free. Then you can add 7. So dynamic arrays, and a lot of times also collections, are absolutely horrible. This is a new. There's a copy. And then there's a release as it grows. And this causes all kind of hell. And so we were not using the arrays because of that factor. This will actually kind of hurt performance in a great way. So so if you ever see any demos or any example code that has collections or has arrays, this class, because we're focusing on real time, we're trying to actually do our patterns without those. So okay, so I'll let you go to show you at the end. I'm gonna give you those drafts, but let's see what the heck these things look like. And so there's the whole tree moving in unison. So, all right. Any quick questions? Otherwise, I'll let you guys go. All right. Well, thank you very much. I'm gonna go to office hours, and if you're around tomorrow, or if you have a certain request you want to see me try to attempt to do, I'm gonna do the coding session tomorrow. Right? Tomorrow's Thursday.
Yeah.
No clue what it is. Okay.
Tomorrow is Thursday.
Yeah, thank you. So I'm going to do a coding session there for those who want it. I think it was beneficial. If people aren't, trust me, I have tons of other things to do than code on a video camera and answer questions. So I'm doing this for you guys, not for my own sake. So if if there's not a need or not a desire, I will stop this. So, all right, thanks so much. See you guys if you're going to office hours. See you in 15 minutes or 5 minutes. Bye.
See ya.
Thank you, Prof.
Thanks.
Bye.